Hello. Hi, everyone. I hope I'm live now. Let me just know if you guys are able to see my screen. I'm really sorry for the delay, everyone. Can I know if my screen is visible and I am audible? Can I know in the chat if you all can see me? Let me just check if we are live. Okay, guys, can you tell me if you all can see me? I think we are live. Okay, great, great. So we'll be starting off with the problems that were today in your contest. I have seen your chat. So yeah, I also think today's contest was pretty good level, and the questions were a bit tricky. So let's start off with the first problem of your contest. Let me just take you to the problem. So this problem says that we are starting off. Solution is right in front of you, but let's start over what was the problem and how we can solve it. So you are given two integers a and b. Find the minimum value of the expression a, this is bitwise and x, plus b bitwise and with x. For this is what your x range is given. X will never exceed the maximum of a and b. So in the function you are given two long types a and b, right? You have to find an x such that you have to find the minimum value of the expression choosing some x, okay, whatever that x is. It is the range of the x. So what is the minimum value? That is what you need to return. Clear? Okay. So let's have a look at the example. So what we are doing in this question is, let me just move here. Let's take any example. Let it be anything. For example, a is, let it be anything. I'm just writing simply Boolean representation of any number that has been given to you. Let it be 0, 0, 1, 0. Okay, and let b be 0101. Okay, for example, these are the two numbers that are given to you. Since the type of a and b is of long type, so maximum bits that we can take can be 64. So now we will see what are we doing. We have to find the minimum value of the expression a, doing bitwise and of x, what was the expression, and plus b bitwise b and bitwise and with x. So what x can you choose such that you get the minimum possible value of this expression? One thing that you have to ensure is that x never exceeds the maximum of a and b. So if we, for example, if your a is 4 and b is 5, so a and your x can never be greater than 5, and it can never be 0 also, because that's what your range of x should be. So let's take two numbers, 4 and 5 only, and let's see what can be the values of what values of x for which we will get the expression, and we will check in what case scenarios we are getting the minimum value of this expression, right? So 4 is 0100 and 5 is 101, right? That's how we represent. Okay, so let's forget about this expression, this a and b, and let's say that we have a this and b is this. Okay, cool. Now what? Now let's start filling up values of x starting from 1. Let's do one thing. What when I take my x equal to 1? Then what when I take my x equal to 2? What is the maximum value of x that I can go? I can take my x till 5, right? So we will put up values. This is one try run that I am doing right in front of you, so that you will be able to understand what we are trying to do with the code that we have written, right? So we will do this dry run for each of the values of x, so that you can get a conceptual understanding of how we are doing it, right? Okay, moving ahead. So let's calculate the value of this expression. A is this a, and doing bitwise and with x. So when I am writing x is 1, what is the bitwise of this x? That will be 001. This will be 010. Then we have 011. Then we have 100. Then we have 101, right? These are the expressions. Fine. Okay, now let's do bitwise and of x with a is 0100. We will do right here 01. I'm sorry, Let me do it here. So just quickly have a look here. 0 0 0 1, this is x, and I am writing a here. 0 1 0 0, right? So bitwise and will be what? 0 0 0 0. Fine. Do the same thing for b. Your 0 0 0, x is this, b is what? 0 1 0 1, right? I am doing bitwise and of x with b. What is the answer you will get? You will get 1, right? Fine. Now these are the two values and you have to add them. When you add them, what is it that you are going to get? So this is 0, this is 1, you are going to get answer as 1, right? Okay, so for x equal to 1, you are getting answer as 1. What about x equal to 2? Let's check. It is going to take a lot of time. Let's come down to what we actually want to do. So if you go ahead and check, let's check for one more time. Let's check for, see, what we have to do is, if I take my x, what I am trying to put up values of x starting from 0 till x, starting from 60 till x can be 0. Okay, these are the values that I am trying to take. And why I am trying to take, see, here I am trying to do bit, trying to check at what position I am getting 1 in x, right? So this is what I have done. This is what I am doing, is I am doing a right shift on 1 by I positions. What does that mean? Sorry, left shift off on 1 by I positions. That means I am checking that starting from ith bit, that is 60th bit, and till the 0th bit of a and b, right? Let's say your a and b both are 60-bit numbers. Okay, what I am checking it starting from most significant bit here, starting from most significant bit of a, let your a be some number, okay, which is like this: 1 0 0 1, so on and so forth, and let's say this is your 60th bit. So what I'm doing is, how do you represent 1? Your 1 is like this: 0 0 and 1. So I am basically left shifting 1 by I indexes, I positions, so that, and doing bitwise and with this. So we have already, means if you're well aware of bit manipulation, you know, when we do bit masking in this way, that I'm converting my 1, 1 has only one set bit, that is at this position. So whenever I want to check if any number in its binary form, I want to check at what position it has 1. So I just make sure that I put a 1 at that position in my number. So I can simply do a left shift on 1 by I positions. That is the position at which I want to find if my number consists of 1 or not. So that is what I'm doing for both a and for b. I am checking if ith index of a has 1. This tells you if ith index at a has 1. How it tells, I'll tell you. If you are not able to understand how this is telling you, then you can write in the chat. I'll go through it and explain to you. Okay, so this, and the same thing is being checked for b. It checks if this condition holds true for both of them. That means at ith index, both a and b have 1 at that position, right? At that position in the binary representation of a and b, both have 1 at ith indexes. If that is, if it does not have 1, that is if it is equal to 0, that means you got, I hope you got the point. Then what you are doing, that means either one of them is 1 or none of them is 1. If that is the case, right, this is what we have put the condition here. Then what you want to do, then again you do a left shift on 1 by I indexes and check if it is less than the, we are trying to set the value of x here. By doing this, we are trying to set the value of x. If it is less than or equal to the maximum of a and b, you return 0. Otherwise, you return this exact value. That's what we have done here. Let me just go through your chat. Yes, I am seeing here. Okay, so so let me just show you. See, in normal cases, in general cases, if I would have started it with 64, it wouldn't have affected. Okay, sorry, 63. The question shouldn't be ideally affected, because what is the maximum number of bits? A long can have 64 number of bits. So I am starting from 63rd bit till 0th bit. So ideally it should be true. But when I try to do a solution using this, then I'll tell you what will happen. You will see why we are failing. Let me submit it. You will observe it yourself. See, it does not pass for input 77, means that's just the observation. Ideally it should pass for 60, ideally it should pass, but in this case, when you try to do a dry run, you take this example and see why it doesn't work for it. So the ideal case that we can take it is 60. This is the reason we have taken 60 here. Not very logical explanation to it, but yeah, that's what you can, that's the observation that we could see from here. Okay, so ith index or ith, see, ith index or ith bit is the same thing here. I'll tell you, look here. If I'm saying ith index, this is zeroth index, this is zeroth bit. So okay, to be precise, I'm talking about indexes. So this is zeroth index, first index, second index, third index, and that's what I'm trying to tell. So zeroth bit, first bit, second bit, you can take it like this. Okay, so this is how we are doing. Now what was the next condition that you guys have doubt in? Let me tell you. See, I'll take an example and show you. So wait, let me open it up. Give me a moment. So what we are trying to do here is, see, so if I am talking about, let's say my I right now is 2. Okay, I'm I am at second index, my I is 2, for example, and my question remains the same. This is A and this is B. What am I checking is, if ith index, that this is 0 first and second, right? The second index, you can see 0 1 double 0 0 1 0 1, right? So you can easily observe that this is zeroth index, first index, second index. Second index, this condition, you are seeing this condition. What is this condition? If your A contains 1 at this position, right? This is, if this is 0, that means it should not be having 1. Basically what they want you, when you are left shifting 1 by I positions, you are doing this 0 1 double 0 and 0 1 double 0, and you are doing a bitwise and what is the result that you are getting? You are getting 1. Is this result equal to 0? No. So this comes out to be false. So this entire condition comes out to be true when you do the and. This condition comes true because this first condition itself becomes false, right? So if condition holds true in this case, if this condition holds true, then what are you checking? You are checking the number that you left shifted by I positions. Is it actually this number? Fine. If this number is less than the maximum of A and B, less than or equal to, which is true, what does this binary representation number represents number 4. So if it is less than or equal to, then you are returning 0. What is the reason behind returning 0? The reason is that this is the minimum value of x that would suffice your answer, and that you will understand when you do a dry run of this condition for all of these numbers. You will observe that, see, when I took x equal to, you have to tell the minimum value of the expression. When I took x equal to 1, I got a 0, right? So this is simply telling me for different values of x, what is the minimum value of expression that I can get, right? So that's what we are doing in this problem. I think the problem is a bit tricky, but it is very easy. The only part is that you have to do a bit dry run on these cases so that you can understand. You don't have to return the exact value of x, but you have to return what is the minimum value of x, that minimum value of the expression that can be returned. So for that, what we have done is we are trying different values of x such that we get the minimum of the expression. And what is the range of x, that you already know, so you are just putting that condition here, and if that holds true, you return 0. Why? Because the minimum value of this expression can be 0 itself, right? And if that does not hold true, then you return the exact of this expression by making x as 1. Fine. So that is what we have done in this problem. So although this itself was easy question, let's move to the next problem and let's understand what is being done there. Let me check what is the Next question. So what was your next question? Virus infection. Okay. So let's have a look at this problem. So this problem is actually easy problem, just that it's a bit lengthy problem, but this is very easy. And I don't know if you guys have tried to attempt that question of rotten oranges. So it's quite similar to that. The only difference is that happens in a matrix. It goes in a 2D direction. In this question, it goes in 1D direction. Are you able to recall it? How many people were able to solve this question? So let's move on. What is the question? So you are given a string S where at some index you have 1, right? Yeah, multi BFS, right? I think a lot of people might have been able to solve it because it's very similar to what you must have already done previously. Okay, moving ahead. So there is a string that has 1 and at some indexes, and there is a value k that is given to you, right? Int k. So what does this question say is that at ith index, wherever you are finding a 1, one has capability, you can say, to infect. One is the virus, one is virus, and it can infect other people by making them also 1. And k is the position that tells you that k positions from that index to the left and k positions from that index to the right, we are making it 1. Okay, so this is how it is infecting. And let's see how can we solve this problem. Let me just write it. Let me also just take a moment. I am going through your doubts and let me collect if there is some doubt that you have not still able to understand. Okay. Meanwhile, you can have a look at this question. Take a read. Try to solve the previous one. We'll start with it in a minute. Okay, so think okay, fine. Okay, so I'll come back to this problem once we are done with all. I'll come back still if you're not able to understand. And let me correct this one. I'll come back with an example why we have started from 60. Okay. So don't worry if you still, because let's cover all the questions as they are lengthy enough and will take some time for explanation. So don't worry, we'll get back to it. Okay, let's start with it. So let me take this example. 00. This is your question. 00 001 001. I think that's what they have given. 100 100. Okay. So what can typically happen is your k is equal to 1, which means all the places where you find 1, that is a virus, and this virus can make all the zeros that are present to it at kth till k positions to the right and to the left, they will also get converted to 1. That means they will also be infected. So you have to tell total how many people will be infected. That means finally how many ones are we going to get in this string. So if you see, this 1 can make this 0 as 1 to its left, because maximum that it can go is at till position 1. K represents that till what positions you can, that person can infect other people. So here it says 1, that means to the left, to the right, both positions will be infected maximum by 1 position. So this will become 1, this will become 1. Next thing, when it becomes 1, this itself has become virus. Now it also has the capability to infect people to the left of it and to the right of it. So if I check to the left, this can also be converted to 1 because it is 0. And if I check to the right of it, it is already 1, so it will not be affected anymore. Now this has been converted to 1. So it itself can convert this 0 to 1 to the right, and to the left they are already 1. Coming on to this one, this 1 can make this 0 1. When this 0 becomes 1, this 1 can make this 0 1, because each virus has capability to infect other virus till 1 positions to the right and 1 position to the left. So all in all, how many zeros got converted to 1? 1, 2, 3, 4, 5, 6. So 6 zeros got converted to 1. So the answer that you should return should be 6. How can we solve this problem? Very, very easy. So what can we do in this problem is, let's create a queue type data structure. Why are we creating a queue type data structure? So if you see in this solution, you can have a look at this solution. What are we doing is, see, we are actually creating a DQ. What is a DQ? I'm sure you must be aware of it, but the only difference between a queue and a DQ is that in queue, you can only add anything, any value at the end of a queue, right? In DQ, it is actually both ways. You can add and remove from both the places. That is, it is like there's a linked list, there's a doubly linked list. Same way, there's a queue, there's a DQ, which has the only difference comes is that you have a function, you have a method to directly add a value and remove a value from first position, that is from the starting of the queue, and means you can do both the things using a DQ. That's the only difference, right? Okay. In O1 of time complexity, the main difference. Okay. Coming on to what we have tried to do here is, we have created a queue. Now what are we doing? We are iterating over each index of this string. Okay. Then I am adding, if I am checking if that is 1, if that is 1, then in my queue I am adding a pair. I am adding a pair which contains that index, and this is 0. Why this is 0? I'll tell you. See, so here I have taken a class pair, you can say. Okay, so this class pair has what? It has two things, which is two values, x and y, by name first and second. Basically, I'm taking two values. It can be anything. You can do it anyway, but I am explaining you this solution so that you can understand. So why I've taken this pair class? This pair class contains two values, first and second. And then I am actually creating a DQ, this queue of type pair, so that when I'm iterating on this given string, see, understand the flow of the question, then coding wouldn't be a tough part for you to do. You just need to understand the flow of question, what is happening. What I'm trying to do is, see, I'm iterating over this string. As in when I get 1, in the first iteration, when I'm getting 1, this means that this is a virus. So in my queue, I am adding a new pair. So this new pair is containing the index of this one, which is 0. Let me write the indexes. This is 0th index, first index, second index, third index, fourth index, fifth index, sixth index, seventh index. So at second index, you are getting this one, right? So I am going to add 2 as the first value of the pair and 0 as the second value of this pair. Why am I doing so? See, this represents this, that this is 0th level. You can take it second value of the pair as level. Level means till now infection has not taken place. You have just found out that this is the first virus you found. And when this virus will be affecting the other virus, that will be of level, that means the next level of virus that has been infected. So I will update, let's say when it converts this to virus, so I will add its pair will include this index, and this second value will be updated to 1. The reason is, it is simply representing the, I am trying to track at what k, means what is the kth position. K represents that you can infect left and right till this level. So what is the level of infection? If it exceeds k, I have to stop, because more than that it cannot infect. This is the reason I have taken a pair of two values, first and second, right? I hope this point is clear to you all. Now, Jaswant Singh is asking, why are you not counting persons who are already one? We are counting it. Wait. Let me iterate over it. What are we doing here? We are counting this one. I found a one, so I inserted this value into Q. Then you move ahead. Next one is found at which position? Fifth position. So you add 5, and what is the second value of this pair? It will be 0. I'll tell you why. I have already told you. Just try to understand. Now what? Is there any other one in this string? No. So in the first iteration on the string, the number of ones that you got, you have added as pair in the queue. Right? This is your queue. Now you will now check, and you will run a loop on your queue until your queue becomes empty. Now what I'm going to do, see, now until my queue becomes empty, I will start removing the pairs from the starting of the queue and do some operations. What will I do? So q dot this remove first, q dot remove first will give me what? 2 comma 0. So I am going to now do what? I have removed it, but I will be adding few values. What are those values? So this tells me that 2 is the index where I found a 1. So I will first of all check if this, now I want to move to the k position to the left and right. So I have to check if this value is not equal to k yet, which is not. So I will move to the left position, one position to the left from this index. So that means I am going to infect a person that is to my left by one position. So what is the index that I'm going to infect now? I removed it, and from 2 I'm moving one position to the left, so this will become 2 minus 1, and the level of infection will be increased because this is the first level from second position that you are going to infect. So what pair will be inserted here? 1 comma 1, right? Okay. Now what? Next thing that you are going to do, you will also check if I can infect person to the right. This is when you moved left, this is when you will be moving right. When you will be moving right, you will be actually infecting person at index 3 and level will be 1, right? Because you are infecting from level 0, now you have come to level 1. Now at third index also, when you are moving to the left and right, you should be having a boolean type array which is telling you which all have been already infected, so that I do not make repetitions to my answer. So which all positions will be affected, I will keep making them true. So 0, 1, 2, 3, 4, these are the indexes of these values. 0, 1, 2, 3, how many? Till 7 indexes. 6 and 7. So far what all have been affected? I have removed 2, so this has become true. Any other has become true. As and when I insert into my queue, that should be true because I am infecting it. So the next that I am putting in my queue. Now what? See, 1 comma 1 you inserted. Now let's insert 3 comma 1. Okay, now I have inserted 3 comma 1. So 1 will be true, your 5 will be true, your 3 will be true. So far these many people have become true, and as and when they will be becoming true, I'm also updating my answer, which will be returning me the maximum numbers that have been infected by the virus. So till now 1, 2, 3, 4, answer must be 4 so far. Now wait, so you have done this thing when you removed. Now your queue first, now the queue has 5 comma 0 as its pair in the front of the queue, right? Now you move to this position, so you remove this and you will try to infect the virus till k positions to its left and k positions to its right. Do the same thing. So what you are doing, let's move to the left of 5 and to the right of 5. So 5 and 0 represents a level you are at. Okay, if I move to the left of it, I will get fourth index and level will become 1. That is this second value plus 1. And if I move to the right of it, index will become 6 and level will become 1. So I will ask my boolean type, are these values already true? No, they are not true. So I can safely add it into my queue. 4 comma 1 has been added. Next value that has been added is 6 comma 1. These are the pairs. Okay, any other can I add? No, not now. From 5 I could only infect these people only, right? From fifth index, right? Okay, now let's remove 1 comma 1. When I remove 1 comma 1, which places can I move? I can, if I move to the left, I can reach to 0th index, and my k level will be increased by 1 and it will become 2. Now wait, this is where you know that your k could be only 1. Your question is given you that at max you can move to the one position to left and right. When your level has exceeded the value of k, that means this is not a valid option to move, so I cannot. And wait, when I have inserted these values, 4 and 6 must have become true. So far 6, my answer has become 6 now. Okay, let me, I am not one thing, a person gets, yes, whichever person gets infected, they can also further infect other people. You have to understand it in this way. This is communicable. You got one person as infected, that one person can infect one person to its right, other person to its left, then that left person has been infected, so it has the capability to move to left and right and infect the other people. No, that, yes, this can be your doubt, this can be your doubt, that yes, like this entire string can be infected. But wait, let me show you an example where entire string will not be affected. See, let's say this is your question. For example, okay, now tell me, if I give you k as 1, will the entire string be affected? Let's check. So the first person is 1, it will affect the other person also, this will also become 1. Okay, let me wait. Yes, yes, Atul got it right. There is a constraint with levels, so you have to stop at that level itself. Okay, so let me show you once. Let me think of an example, or let us check if we get it. So in this case, also the entire string will be. I'm thinking of an example where I can show you. Let us take this example. Okay, and let's say I tell you that two people get affected, then they have the capability to affect other two people. Wait. Okay. So see, your doubt is correct. I'll tell you. There are always, in most of the cases, the entire string might get affected, but eventually you have to tell that how many zeros got converted to one, right? That's what you have to do. So if you try to see 1 2 3 4 5 6, 1 2 3 4 5, I think if we do it, just give me a second. I'm just thinking of one thing. I am trying to, give me a moment. I'm checking out something. See, for int. T. The case is, let's say there is no one at all. There is no one at all, right? 0 0 0. In such cases there will be no infected, right? So in that case what will you return? Obviously if you try to do it other way around, see, your doubt was that every time the entire string will be affected. So let's do it in this way, that count the total number of zeros in your string. Okay, count total number of zeros in your string and return it. We can, if you try to do that, were you able to complete it? The reason is, either you handle cases where the string does not contain anyone at all. In that case there will be no infected person, right? Either you do it that way, but this is the method. See, this is the method which has a proof of concept. Okay, so we are trying to do it in this way. That's the aim of this problem. Okay, let me know if you still have any doubts. Right, you got the example correct, that you have k equal to 1. There is one way that I tried that, okay, let's calculate how many zeros are there in that string, okay, and return the answer. But why does not that it does not work? Because there are a lot of edge cases that it will probably miss. So we do not have a proof of concept for this, for that particular solution. Okay, let me know if any one of you was able to solve it using that method or by any other method. Meanwhile I am checking one more approach. If that works for you guys, I'll let you know. Give me 1 minute. If your test case is, let's say, I think, just a sec. Mm, what am I thinking is, see, the question again, same thing. Let me see what is your doubt. Answer is 304, 1, 2. Let me know what test case you want me to take up. I'll take up that particular test case, because I'm not sure which test case you guys have doubt about. If I talk about one, let's take this example, one with 4 zeros. Okay, let's take this example. I'll tell you what should I actually happen. 1 2 3 4, let's say, and k is equal to 2. So what will happen is, first this 0 will become 1, this 0 will also become 1. Now this 1 can make this 0 1, or this 1 itself can make this 0 1. Eventually all the zeros will get converted to 1. This is what your output should be, that finally you will return 4 as your answer. Because whichever one gets infected, it has the power to infect two more people to its right and its left. So no matter it is infecting that person or it is infecting that person, anyway this zero is getting affected. So that's how you have to see the question. Okay, so I think you got it. Let me know if you guys have tried it with this method. See, if I try out with this method where you are checking number of zeros in that particular string, let's check how many zeros are there. Okay, I hope you all understood this question. We will move to the next problem, but let me just show you the code. So what we were trying to do, we were inserting each of them in this queue, and while we were removing that value from the queue, we were inserting a new value with a check. If it is not exceeding k by this second value, I'm keeping that track using this second value, and this represents the index that I am inserting. So these things you are doing, and you are doing until your entire queue becomes empty. Now if I remove 3 comma 1, 3 comma 1 has the capability to infect what? One position to its left will be 2, and this level will become 2, and one position to its right, that is 4, and level will become 2. So it fails due to two reasons. Because 2 is already infected, you can see in this boolean array, and second thing is that k has exceeded the value of 1, so this will be denied, this will be denied. And for 4 comma 1 also you can move to 3, which is already true, and k will exceed its values. This will also not give you any answer. When you will try to remove this, it will also not give you any answer. So final answer that will be returned is 6. So that is what we have done in our code in BFS solution. So this is the reason we have used q here. Let me show you back. So the thing that I've explained to you, we have taken a boolean array, right? Then we have filled initially it with false. Then we have taken a q, dq to be precise. Then we are iterating over each character of the string. If that character is 1, I'm inserting a new pair into your queue with that index and that level at which it is. So at first iteration, the level is going to be 0, and you are also updating your boolean array. And as and when your boolean array gets updated, your answer also gets updated, because that is how many people you are affecting now. Then you are, until your queue size becomes empty, you are removing the first pair from your queue, that is q dot remove first, and then you are checking if f dot second. So second represents the level. If it is less than k, then you try to insert that value, you try to insert and ask boolean array. If it is already not true, then you go ahead and do this thing. The same thing you are doing for left position, the same thing you are doing for right position, and that's how you finally return answer. I hope this question is clear to you. If you have any doubts, you can ask me, and let's move to the next problem. Let's see what is our next problem. Which one is this? LCA pairs. So now these two questions are actually tricky questions, and these questions are graph based questions. So let's see what is LCA pairs. You can see it here. Not this one, this is the one. Okay, so LCA pairs, this question you can see is quite a bit, not quite a bit, completely implementation of DSU, disjoint union set, if you are aware of it. So what you are given, you have to find the not this question. LCA pairs, right? One second, we are doing LCA pairs. Okay, so this is not the DSU one, other one is. In this question, you are given a connected tree of n nodes. Okay, you are given n nodes. This is the parent node, which tells you what is the parent node. What you have to return in this question is calculate the number of pairs of nodes such that LC of A and B is X. Basically, for each parent, for each node, you have to tell how many pairs are possible if that node behaves as an LCA. I'll explain this question to you very well in when we take an example. LC, or lowest common ancestor between two nodes A and B, is defined as the lowest node in tree that has both A and B as descendants. Let me explain to you what they are trying to say. See, if I take this example 0 1 2 3 4, let me see if I can copy it so that I will explain it. So if you see in this question, this tells you that zeroth node has parent 1. First node, there are n nodes, okay? There are n nodes and they are numbered from, let's check, they are numbered from 0 to n minus 1. So zeroth node has parent minus 1. That means your tree is starting at zeroth node like this. Then first node has parent 0. So this is telling you how your tree looks like. So if I follow this parent structure, I'll get a tree. 0 has parent minus 1, which means 0 is the root of the entire tree. Then one node has parent 0, that means 1 is connected with 0 like this. Then second node has parent 0, which means 2 is also connected to 0 like this. Then you have 3, which is a descendant of 1. Then you have 4, which is also a descendant of 1. So that's how you're forming your tree. Okay. Now wait, what do you have to return for each node? Each node you have to return the number of pairs for which these nodes can act as LCA, least common, lowest common ancestor, which means, see, and also in this question they have told you that you should consider that node itself as one of its own pair for LCA. So if I talk about 3, how do you see any other node that is connected to 3 as its descendant? No. So for 3, if I tell you, you have only 3 comma 3 as its pair, which is its descendant. You can say 3 is the LCA for 3 comma 3. Same goes for 4. 4 has only one descendant, which is its node itself. So that's how you are I'm just explaining you that how you are trying to find the LCM. Now for node 1, what are its descendants? You can see node 1 has two descendants, 3 and 4. So what pairs of nodes can one act as LCA? LCA is the node which is directly connected to the descendant and is the is at the lowest possible level from its descendants to become the parent for those nodes. Okay, so if I talk about this subtree is directly connected to which node? This node. So this will act as its LCM. Can 0 be its LCM? See, 0 is forming a root for this subtree, but the lowest possible one for this subtree will be 1. That is why for 1, if I want to know what are its descendant pairs or what are the number of nodes for which 1 can be LCA, is first of all 1 itself, then 1 comma 3, right? For a subtree which contains only 2 nodes, what is going to be the LCA? 1. For a subtree containing only these 2 nodes, what is going to be the LCA? 1. So 1 comma 3, 1 comma 4, and other one will be a subtree having 3, 4 and 1. So that will be 3 and 4, right? So how many pair of nodes are coming out to be descendants of one for which 1 is LCA? 1, 2, 3, 4. So for node 1 you have 4. For node 1, we have 4 such pairs. Now let's check for 2. For 2, again, we have no descendants, only one descendant, which is 2 comma 2 itself. Let's check for 0. For 0, we are going to have lots. First is going to be 0 comma 0. One is going to be this subtree 0 comma 2 pair. One is going to be what? One is going to be 0 comma 1 as a subtree 0 comma 1. Next, what? One is going to be 1 2, right? We can have 1 2. Yes, we can have 1 2. Then one is going to be 0 and 3. 0 and 3 for a, imagine a tree which is a skewed tree, 0 1 and 3. So in this case, if I talk about nodes 0 and 3, what is going to be the LCA of 0 and 3? Obviously 0. So 0 comma 3. Then we can have 0 1 and 4 as one of the trees, so 0 comma 4, right? I think then we can have a tree having like this 2 comma 4. We can have a tree with 2 and 3. So these are the pairs. So total 8 pairs are found. Okay, let me check if I think you got it right. Answer for vertex V is equal to size of subtree plus size of left subtree into size of right subtree. See, I'll just show you the code. You will see that there is a little bit problem here, which is, see, what is it? I hope the question is clear to you. Now, what are we trying to do in this question? In this question, we are actually applying depth first search. For each node, taking that, considering that as the root of the tree, we will be checking for each node how many pairs are possible if it becomes a subtree. So basically, it's a DFS process. The only thing is, this is how we are applying the formula. This is how we are applying the formula for each sub. That's the only difference. The entire thing comes down here. If you have tried to attempt this question, you will observe that the difference comes at this place. See, what we are doing here is, first of all, in this question, there are a lot of things that we have done. The tree that we are given in the form of an array list, I have converted that to a graph. A graph here is an undirected graph. You can see that. So I have added edges to that graph. Then we are applying depth first search on the graph, starting with index, starting for vertex 0, having parent -1. So in my DFS function, I'm passing two objects. One is vertex, other one is parent, right? Two arguments. And how we are creating a graph that you can see in this class graph. So it takes some time. Try to see what we have done here. We have created a class graph where actually typically your tree is going to look like this. See, you have 0. 0 is connected to what all nodes? It is connected to 1. It is connected to 2, right? Then you will be having 1. 1 is connected to 0. 1 is connected to 3. 1 is connected to 4. Okay. Then you will be having 2. 2 is connected to 0. Okay, this is how my graph is going to look like. 3 is connected to 1, fine. 4 is connected to 1. Then do we have any more? 0, 1, 2, 3, 4. So I think you can see this 0 got connected to 1 and 2. 1 is connected to 3, 0, 3 and 4. These three. So this is how I'm adding edges from each vertex to the vertices that it connects. So this is what you need to understand. If you are creating a graph, so this is how your graph is going to look like if you create it this way. That is written in the code. Okay. Now, what is the next thing we are doing? Next thing, so this is how a typical graph is made. So I'll not get into dig deeper into it because this is basics when you try to create a graph. Coming on to DFS. So entire thing is that how we are calculating subtree size. First we are calculating how we are doing it. See, we are going down at each node, right? We have created a boolean array which is tracking if that node has already been visited or not. Typical DFS thing for a graph. Then when I'm starting, I'm initializing my size with 1 and sum is telling me what is the total number of pairs that I'm going to get for that particular node. Okay. Then this is an array list I've created temp. Now I am going ahead and applying DFS for each edge, for each vertex. Basically, adjacency list dot get vertex. What this represents? What adj list? See, adj list dot get source dot at destination. So this is your adjacency list. This is your adjacency list. Okay, for each vertex of this list, let's say when you are checking for 0, for 0 you are going at 1. Okay, for 0 you are going at 1. Then you are, let me show you. Then what is happening? You are checking if that itself is not its parent. Okay, then you are computing the size of it. How will you compute the size of a subtree? Our focus is to calculate the size of the subtree. From 0 I go to 1. Then 1 is telling, then 0 asks what is the size of the subtree from here. Then I go to its immediate vertex, which is 1. From 1, I do the same thing. From 1, what are the nodes that 1 is connected to and is not its parent? So when I go to the adjacency list of 1, I will find 0, but this condition will hold false. That is, it should not be its parent. This condition, let me show you, this condition will not hold true. We are doing this thing for each vertex of that particular node that it is connected to in the graph. So I will go to this node now. For 3, when I go at 3, I will check what is the size of the subtree starting at 3. So when 3 will not find any other node, it will return the value of its size, that is 1, right? So it will return, basically what we are doing, by trying to find the size of the subtree, we will find out what is the number of pairs that I can find for any particular node. Okay, and how are we doing it? So size is going to be added. We are applying DFS. Once, let's say we are at node 3, then we have no more nodes to see. Then what we will be doing, temp.add. Temp is the array list where I am adding the subtree size. It means for that particular node, what is the subtree size that I will be storing in subtree size. Anything you can create. I've created an array with name subtree size, which will be adding the size of that subtree starting at that node adj. Okay, then what is the sum? Sum will obviously, that will be the total from DFS, what all we will be getting, we'll be adding it. Then what? See, total answer of the pairs will be what? So in your temp, what all things you will be having? You will be having the subtree sizes for different nodes that that particular vertex is connected to, right? So what we are doing here is x into sum minus x, and then how this is giving me answer. Has any one of you tried using this formula and you got right answer? Let me just see if any one of you got answer using this formula. I think Saket Ghosh, you got pretty much correct. In fact, it's appreciable that you were able to crack till here, that you were trying to find the size of the subtree. Then you are adding size of left subtree and multiplying it with size of right subtree. But this might fail for lot of test cases. The reason is what we are doing here. See, this is the thing that you need to understand. I'll tell you, give me a second. Let me take a better example. If I might have it. I think what you have done is correct only. Size of sub, you are taking size of subtree, that is fine. Then what you are doing, you are adding it to the size of left. But okay, fine, I got it. So the same thing that you have written, we are doing it, just that we are taking the total size of the subtree, we are calculating the size of one part of subtree, be it left, and then the right subtree's size will be what? Total size of the tree minus the left subtree size. That's what we are doing using this formula. So basically, for each subtree size x, we are calculating the product of x and sum minus x, which represents the count of pairs where one node is in the current subtree and the other is outside the subtree. Got it? So we are adding that result to find the total answer. That's how, let me show you that screen. That is how our function is working. That's how our formula is working in this case. Is this the problem? No. LCA pairs. See, this is what we are doing. So in this case, what we are assuming is that one of the node is present in that subtree and rest is outside that subtree. So this is how we are calculating it. Then we are adding the size of this subtree. And what next? Actually, that's pretty much about this problem. You have to first, what we have done is we have created a graph class so that I can convert this into a graph where I have an adjacency list, right? So using that adjacency list, I am trying to go over each subtree of my tree, each subtree, and from each subtree, I'm finding out the size of the subtree, and using this formula, I am checking what are the total number of pairs that I can get for any particular subtree. And that's how you can manipulate your answer for each of the nodes. So each node, this is 0th node. How many nodes pairs it will be having, that will be 8. So if you do one dry run, if you do using this function, you will be able to understand. I'll make it, I have made it short for you. You just do a dry run considering this is your adjacency list, and now you apply DFS on this list. You don't spend time on, means while you dry run, don't spend time on how your converted tree will look like. This is how it's going to look like. Now you iterate over it and apply DFS, then you will check for yourself what we have done in this question. Okay, take a minute, try to have a look in this code if you want. I'll scroll down one by one if you want me to, but this is about this problem. You can have a look at it. If I think one of the person already got it correct, that we are actually doing with this formula, what we are doing, we are basically checking if there is a subtree whose root is this. Okay, whose root is, there is a root and we have a subtree. With this we are finding out the number of pairs considering that subtree of which that vertex is part of it and outside that subtree. So this is outside the subtree and this is the number of pairs that I will get from the subtree of which that particular vertex is part of. So that is how we are calculating it. Let me see what you guys are if the LCA. I think you got it right, Saikit Ghosh. And let me give you the code in the comment section. Have a look. See, the question is obviously lengthy enough and obviously not something that can be quickly taken. To be honest, this is a very good question, and there are a lot of things that I'm assuming you should be knowing, that how we are converting an adjacency list and all of these things. If you know, then this question can be simpler. Otherwise, you will have to go through each and every part of this question, do a dry run, and then you'll be able to understand. Okay. I think it has come in lots of parts, but I hope you have gotten your answer. I think it's no, it hasn't completely come. Let me check if you have got the entire answer to this question. Let me. I'm trying to paste, but I don't think so. It is taking up the entire question. See, I think you'll have to. I don't think so. It is taking anything. Yeah. Text limit is exceeded, so it will not come after it, I'll separately write what is after this line, after sum minus x. So what do you have after sum minus x is this. You can paste it from here. Because the code is lengthy, the comment section is not allowing me to write more than that. So this is what it is. Some issue. Okay. I'll take you to the back to the code. You can see is done. And also take care that they expect of type long. So we have taken here of type long. So okay, let's move to the next problem. We are going to do special graph. Okay. Again, not an easy problem. There are few things that in this problem that you will understand only when you try to attempt after understanding this problem, that are why we have taken values like what is the range that we have taken. So I'll tell you why, but let's move on to this problem. Okay, what is more important here is this, that you have to analyze that what can be the possible range of this expression. This is how, let me explain you the question first, then I will move to that part. I think we are good to go. Okay, fine. Coming on special graph. So just let me know in the comment section how many of you are comfortable with DSU or have done questions on DSU topic of graph. So DSU is disjoint union set, which is a topic which you study when you try to learn graphs. So how many of you are comfortable with it? Or just give a heads up in the comment section that how many of you have at least attempted any of the DSU question earlier, or you know what DSU is. You can have zero idea about DSU, that is also completely fine. I just want to know that how many people here not studied, okay? Because I am assuming it's not that a lot of people must have done. It's completely okay. And equipping, okay, you know DSU, that's great. Okay, so for very good, good to know, good to know. So for those people who have studied DSU, I'll cut to the chase that this problem is actually simple DSU implementation with few things. What are those few things that we are actually using this here? What we are doing in this problem, I'll explain you the entire question, but for those people who have attempted this question and know DSU, I'm just telling you that it's DSU implementation with some parameters, like we are taking a range such that x and y get covered in that range. So that is the trick, that how do you understand that we are taking a range such that your j is less than or equal to 3 times n, and this is the array list that we have taken of size 3 times n plus 2. So these are the things that are challenged in this problem. Okay, moving on to the problem now. I'll try to, for those who have never studied DSU, I'll try to give you some hints or glimpse of what DSU is, but I cannot be explaining entire DSU because that itself is a topic you will have to learn in order to understand this question. Okay, so you are given an array A of n integers, okay, Consider a complete graph of n nodes numbered from 1 to n. So this graph has nodes you can consider from 1 till n, where the weight of edge connecting nodes x and y. And this is some expression which gives you weight of nodes from x to y, okay, which is x into y minus a. So this is an array which has some values at certain indexes. So those indexes have those values, and using them in this expression will give you the weight of that particular node. So this is modulus, okay. You must, this is now what I was talking about, modulus of a plus b. You guys know how we, in mathematics, this comes down to 11 12th question, how we used to find the range of a modulus mod. You remember modulus, you remove the mod, then you know that a plus b can be less than or equal to, greater than equal to that minus and plus thing. So if so that thing you have to do mathematical part, and for that you need to know why I'm saying this, because you need to know the range of x and y, okay. So when you take out this modulus, you will weight can never be, see, we have graph of two types, we have a positive weighted graph also, we can have a negative weighted graph also. That is why they have given you modulus here. Got it? So your task is to find the cost of the minimum spanning tree of the graph. Now what is an MST? The cost of a spanning tree is the sum. So cost of any spanning tree is the sum of the weights of all edges in the tree. What kind of a tree can you create such that that cost is minimized? Okay, there can be many spanning trees. Minimum spanning tree is the spanning tree where the cost is minimum among all the spanning trees. I hope you again little bit understanding of what question is. See, I'm not saying it's not at all an easy problem, and for those who have very little idea to no idea of DSU, is going to be really difficult until you understand what that is. But let's try to understand bit by bit what they're trying to say. So in that you need to know what is an MST now, minimum spanning tree. So a tree can have weights. So they have given you that there are some weights associated with each edge. For example, there is an edge 5, I have an edge 4. In a lot of ways I can draw a graph. For example, I have nodes from 1 to 5. What can be the graph that I can create? Maybe this kind of a graph, this can be graph, this can be graph, or maybe I can draw a graph like this: 1 2 3 4 5. This can be a graph, maybe this can be attached, maybe not. So you can have multiple number of graphs. What this question asks you is, what is, in which way you have to return the weight of a graph in which the weight is minimum weighted graph. And how do we calculate that minimum weight? Basically, not minimum weight, the cost of the minimum spanning tree of, you have to find the cost of the minimum spanning tree of this graph. Now I already told you what is the cost of a spanning tree. Cost of any tree is the sum of weights associated with that graph. So for example, weight associated with this edge is 10, weight associated with this edge is 5, this is 1, this is 2, this is 3. So what is the sum of all weights in this type of graph? 10, 15, 15, 5, 20, 21. This graph gives you weight, total weight of the graph is 21. So let's see, if I draw this graph in this way, what is the weight I'm going to get? So 4 to 5 is 10. Do I have an edge from 4 to 5? No. 2 to 5, there is no edge here. Basically, I've just randomly drawn a graph, but we don't know what is the weight right now. But we have to consider 1 to 3 is 3. 1 to 2 here is not connected. Let's take anything. So the whole point is, from given weights, from a given vertex edge, you can draw multiple graphs, but you have to return the minimum cost of such a graph that you can create, in which you are given a array containing some values, right? You can consider edges x and y, and weight between, let's say there is one x edge and where there is one y edge. if you're trying to connect them in whatever way, the weight between them will be determined by this expression. The expression is this that they have given here: x into y minus ax modulo ay minus ay modulo ax. Okay, so your task is to find the cost of the minimum spanning tree of this graph. Okay, why I'm kept on repeating this question? Because it's not very easy to understand. So that's why I'm saying. So there are lots of possibilities to create this graph. Which is that graph in which the cost of the tree can be the minimum? That's what you have to do in this question. Fine. So let's see what this example. Here they've given you output 10. One of the MST of this graph will be, they have created a graph which is looking like this. 1 is connected to 2, 1 is connected to 5, 4, 2 is connected to 3. There can be other ways also in which you can connect 1, 2, 3, 4, 5. Now, when I connect 1 with 2, what is the weight I can get? So if I connect 1 with 2, x is 1, y is 2. You have to know what is a of 1. So this is the a of 1 is this, a of 2, right? And then what? These things you will put up in this formula, in this expression, and find out the weight. Okay, so using that formula, when you know what is the weight, you will see that out of all the possible explanations, this is the graph which will give you the minimum weight. So cost will be the weight of edge 1 to 2 plus weight of edge 1 to 4 plus weight of edge 1 to 5 plus weight of edge 2 to 3. So this is the weights that you are getting. Now the question is, how do we find such a graph? How do we find such a configuration in which we are getting the cost of the minimum spanning tree? So in DSU, what typically happens is we do two things. We typically do two things, which is, first of all, let me tell you, DSU is disjoint union set. Disjoint union set. Okay, so what do we try to do in this is that, let's say you have edges like 0, not 0. Let me start with 1 only. 1, 2, 3, 4. Let's say you have edges 1, 2, 3, 4. As of now, there is no parent. So I will consider that person itself as its parent. What is 2's parent? This is representing that 2 is the parent of itself. 3 is the parent of itself. 4 is the parent of itself. Okay. So I am trying to find who is the parent of any particular edge that I'm talking about. Now, what is typically happening in this question? This is an MST. So if I ask you parent of 2, you will tell me 1. Parent of 3, you will tell me 1. Parent of 4, you will tell me 1. Parent of 3, immediate parent is 2, but 2's parent is 1. So you can say that 5's parent, not immediate parent, 5's representative can be 1, right? So this is typically what DSU does. It actually finds the representative of any particular node. If you do not find the representative, you try to merge it. For example, you have a graph like this, 3, 4, and 5. And you have a graph like this, 2 is connected with 7. When I ask you, find is a function, find is a function which will find the representative of any particular vertex. So if I ask you, find the representative of vertex 4. So ideally, your function should return you 3. Then in my find, I will ask what is the representative of 7. So it will return me what? 2. Fine. Now, for example, if I want to merge them, okay, I can merge it with the parent of this 5 so that I can have the representative of 7 and 4 as same, which is 3. So when and how do we take, so this is known as, first I find and then I do its union. So this is what is union function is doing. So in this problem also we are doing the similar thing. First we want to find the representative. These are the ways in which we can find out the minimum spanning tree, and how we are calculating their weight. This is done in this part of the problem. Now, how we are calculating, doing, let's see in the code. First, have a look what we are doing in this question. For those who have tried to attempt, you must be getting that how we are solving this problem by creating a DSU class. how are we creating a DSU class? We have typically used two functions here, major functions, which is first, it is finding the representative. Here I have represented that representative with root. Basically, for any vertex, I am finding what is the representative of X. So it will return you, right, that representative. And if when I'm giving you two vertices X and Y, this merge function is doing the task of union function. Fine. So for that, you must know how DSU functions work. You need to know the implementation. If you know, you will be able to understand what we have done in this part of the question. Okay. Now, coming on to actually calculating what is going to be the cost of such a minimum spanning tree, let's understand. So we have taken an array list of array here like this, okay, and now I've taken size of 3n plus 2. Why I have taken this? So if you try to calculate the range in which both x and y will fit, okay, so if you take a size of 3n plus 2, you have to do this on your own, means there you have to track down, jot down some examples. If you try to take just size n, when I just proceed ahead, you will see that we will not be able to cover all the possible values of x and y. This is the reason. This is this is the thought process that went behind, which is to know which is basically knowing what can be the range of x and y, such that this expression can hold true for all the cases. That's why this is the size of array that I've taken. Now what we are doing, so now we are filling up this array. This is the initialization of it. Now starting from, we have nodes from 1 to n, right? So I start from 1. Now I is at 1, j is at I plus 1. I into j is less than or equal to, so this is nothing, this is basically this, that we have taken this size. So how can we manipulate it? So I have taken I into j is less than or equal to 3 into n. So if you try to consider I as x and j as y, right? There are two vertices, x and y, where I, you can assume I to be representing x and j to be representing y. So what is the maximum till which I into j can go? And then you have to make sure that I is not exceeding n, and since we are putting this cap, we have to also ensure that j does not exceed the limit, which is n, and that's what you are doing. Then you are calculating weight using this expression that has been given to you. We have used math dot absolute. This is the method that we use when we calculate the mod value, basically mathematical mod value. So we have used this function where I told you x is I and y node is represented by j. That's what you are doing it here. If your weight is less than or equal to 2 times of n, what we are doing, we are adding that weight, and corresponding to that we are adding what x, and corresponding to what y, we are getting that particular weight. You got it? So this is what we are doing it here. And then once we are done with this, we are also, then we are creating a new, this is a disjoint union set that we are creating for DSU. Now this is something that we have done here in DSU. This, for this, obviously you need to know this union and find function. And finally, once we are done with that, we are iterating over variable ID I have taken, so that there is no issue of what type we are iterating over. So for each, this ed is this array list that we have created. For each of it, we are doing a merge. So after creating DSU, we are just doing that union and merge thing. First, we are trying to find it here in this function, okay, and then we are merging it from x and y, and also simultaneously we are adding it to our answer, and finally we are returning it. So that is what typically we are doing in this question. Let me see if you guys have any doubts. So this is actually about this problem. So guys, that is all for today. Take some time. I'll give you this code as well in the chat. Try to reattempt it and do dry runs. Until unless you dry run, you won't be able to understand. If I keep start doing dry run on each and every problem, it will take a lot of time, because each example has good amount of length for each question in this contest today. So I am not able to take each and every problem and dry run it to the end. That is why I have to do it like this, but I really want you to do it on your own so that you can understand it better. Let me give you the solution. So this is your class solution. I'll give it in parts. Okay, I'll explain to you. Just wait for a moment. It's coming in lots of parts. Okay, so see, tell me one thing. How you used to calculate the range of any modulus a minus 3? We used to remove the mod and calculate a minus 3 can be greater than 0, less than, then a minus a plus 3 can be less than 0, something like that, right? So for that, this is literally not related to coding and programming stuff or some particular topic related to graph. This is completely mathematical, how you used to calculate range of a mod function. This thing we have studied in like class 12th or 11th. So this is nothing. We have an expression. Let me show you what is the expression. Where is it? Special. So we have an expression like this. Okay, let me copy it. We have an expression like this, and we are trying to know the possible value, possible range for x and y. So if you see, if I simply take my size of that array to be n, I will not be able to fit all the what I'm doing here. See, I have to fit in values of x and y so that I can get some the minimum value of this modulus function, right? That's what I want to do. I want to create a graph where I can get a minimum value of this modulus function. So what such x and y pairs I can take, not x and y. I know that what is the range of x and y going to be, but why we took 3 into n plus 2? Because what, how we are filling our ed, how we are filling our ed array, that you will understand once you iterate over this function. Then you will observe, if you just take array list size to be n, you won't be able to fit in all the possible values of x and y, because see, your j is ranging from I plus 1, and basically your I into j should be less than or equal to 3. That's what 3 times of n, that's what we are typically doing, and this is the obvious case that you all know. So you have to once go through it, or you try to find the, how mathematically, how do you find the range of a modulus function. That's what you have to do in this question, otherwise you won't be able to understand why we took 3n plus 2. Okay, let me see if you guys. I'm trying if I can show you one example where we are actually calculating it. So see, there is not any legit logical thing that we have used, or that this is the formula, so we always take like 3n plus 2. No, the it was only due to intuition. What was the intuition? That what all x and y, what are the possibilities of x and y that can fit. So you can take it 5n plus 2 also, but it will be unnecessary repetition, it will be unnecessary execution of code, right? You try it with 2n, there is no issue. If your code works good for you, we're just expanding the size. No matter, some size might remain unfilled, that is okay, that is okay. But our task is that it should not be small enough so that x and y may not be added. So this is not the first time we are doing. In a lot of graph problems, we take an extra the size of the array or any data structure that we are taking, we might end up taking extra size so that we do not end up with some values of x and y that remain unfilled. This is the reason. There might be some thing that might be unfilled, but that is okay, that is okay, that will be handled. Okay, so this is behind this, nothing else. The factor of why we have taken this factor, just to ensure that all possible weights are considered, because you have this modulo of x into y minus all of these things. So considering that into consideration, we took this value. You could have taken 5 times n also, but I think that would be very unnecessary use of space. That is why we chose it. Okay, so let us check if you have any more doubts. Okay, sure. Let me come back to that thing. Give me a second. I'll just copy down this code also. I'm sure you must have done this, but let me write it. Fine. Coming back to it, just let me take an ideal example so I can show you. See, again, as I tell you, first of all, we are trying to start from the most significant bit. Now, since this is of type long, obviously we would want to start from 63rd bit till I equal to 0. But why we started from 60th bit? Because see, 0, 1, wait, 63rd, 62nd, 61, and this is your 60th bit. Okay. What we are trying to check is, see, in our problem, what we have done is we are starting from the most significant bit, and right, and we're iterating towards the least significant bit, right? We are starting from here and moving to this direction, and in our question we are checking if that bit is set or not. So basically, there again, same thing, there is no hard and fast rule. Only for this problem I also started with 63rd bit, but it failed for cases. That is why I came down to 60. The reason is, the understanding behind this is that you are basically checking the common prefixes. Okay, if you see a and b, if there is any common prefix, that might return you 0. And what can be the possible case? Let's say in a other question, means in other, let's say this is a and this is b, right? So if both the bits are not set, right, that's what we are doing in this part. If both the bits are not set, if it is 0 and it is 0, that means it will return you 0. In that case, you are doing this and this thing. So the only reason behind this is to ensure, by starting the loop at 60, we are checking that it is effectively iterating over each bit from the MSB, that is the most significant bit, to the least significant bit, nothing else. And the only reason was that it failed for 63, so we tried with each bit, it failed, and 60 will ensure that every bit is getting covered. This is the reason we are doing, because we are actually finding the common prefix for A and B starting for ith index bit. That's what we are basically doing in this question. And now if you try to if you want me to repeat it, I'll again repeat it. But if you don't understand so far, then you'll have to do a dry run. Only then you will be able to understand. See, the reason is, here in this question, we can't take a number which is representing total 64 bits, right? It will be a very big example. That is why to satisfy you using that particular example won't be possible as of now. That is why I'm telling you, have to little do it on your own so that you can understand why we have used 60 and not 63. That's the only explanation to it, nothing else. Anything else, guys? You can ask me. I'll check. I'm sure that you guys must be a little confused because of this thing. I understand that, because see, all of these questions, I'd say virus infection was an easy one. To be very precise, this was an easy one. Min was also an easy question, but yeah, this thing was tricky. I think you must have also, if you were able to reach till here, you must have also tried it using 63. I also did the same. But then I realized, a few examples I wrote, I realized that if I start with 60, then also all my cases for A and B will be covered. Because what I'm basically checking, that I'm checking what is the common prefix of A and B for that set bit at particular index I. So if I take 60 also, then also all of my cases will be covered. This is the reason this will not give you any error, right? And that was all. K, where K, second problem was virus infection. Okay, see, Vikram, I think, who is it? Vivek. So I have explained why we have used K. You need to go through the question now, because K is explaining you the levels, right? What is K giving you? That for any particular virus, maximum that you can infect is one. For example, if you take this case, third person can infect one person on his left and one on his right. Fifth person can do the same thing. The person on the left of fifth already got infected by the third person. So if I take an example 0010, or let's do a custom input. You guys were telling me some custom input, right? Let me take your example. Which was it? 4 times 0 and K equal to 2. Let's do a custom input, then I will come back to it. And this was 2. So let's see what is the answer. 1, 2, 3. 1, let me show you. 1, 2, 3, and 4. Okay. So in our queue, we first added this one with index 0 and our label was 1. Okay. And then in visited Boolean array, you marked this index true. 0, 1, 2, 0, 1, 2, 3. 3 and 4. Let's check why it is giving us 3. We will understand this thing. So when I will remove this, now there are no ones in this particular question. When I remove this particular case, then what are the possibilities? Let's look at our code. What will it do? When I remove it, q equal to remove first. I will ask f dot second. What is f dot second? That is, sorry, it should be 0 because it was level 0 only. So it will check f dot second is less than 2. K is 2, it is less than 2, true. I will go inside. F dot first minus 1. I will check if I can infect the left side person. If it is greater than or equal to 0. So f dot first is 0. 0 minus 1 will be minus 1. So this condition will not hold true. So let's go to the next condition. Next condition is this. Can I go to the right side person? Yes, I can go to the right side person. That is at first index. I will infect that person, add to my Boolean type array visited of f dot first plus 1 equal to false, then q dot, in my q I will add with both the values will look like this. From here I am going to infect this person, which will be making this index will be 1 and the level will also be 1. Okay, and simultaneously what is happening, that your visited of f dot first plus 1 will become true. Okay, so f dot first, this is 1 and this will become true. Got it? Okay, now what, visited or this become true and answer has been incremented to 2. Now next thing is what, again your q size is not 0, so you remove the first one, you remove the first one, that is, this was already removed, now you remove this. When you remove this, you will check f dot second is less than k. What is your second value? Your second value is 1. Yes, it is less than k. So let's check f dot first is greater minus 1 is, yes, it is greater than or equal to 0. I can infect this person. Basically, it is trying to go back to this position. I can infect it, but let's see if we can do so. I can infect it if f dot first minus 1 is equal to false, which is not the case. It is not false. It is already infected. It is already true. Okay. So this condition will not be true. I will go to the next condition. Let's check f dot first plus 1. Yes, it is less than n. So visited of f dot first plus 1. I am removing this. So the next thing that I will be inserting will be 2 comma 2, right? And my boolean was already false, so it will also become true. Your answer will be 3 by now. Fine, your answer will become 3. Now go to the first line of this loop again and remove the first pair. Now I'm removing this one. Okay, can I go to its left side? First of all, you check f dot second is less than k. No, f dot second is not less than k. So from here, if you see, now what you are trying to see from here, f dot second plus 1. See guys, what was happening? We were trying to infect people from this position to two positions. From two positions, I've already filled it. Now I cannot go to its, can I go to its left or right anyway? No. Why? Because at this level, it has already infected two people. So the maximum that it could have infected was two people only. You getting this point? And the next reason is why I couldn't, in my queue, there are no other people to infect. When I see, I converted this into one. When I converted this into one, it got removed from the queue after infecting the other person, that was this. But simultaneously, the reason they were getting infected, the levels were also increasing. That is level of k. K was also increasing for this particular node. So due to this, total people who have been affected so far have reached that value of k as 2. So no matter what, this person will not be contributing in affecting other people. Okay, fair enough. But do we have other people to contribute? Our queue is empty. We do not have more people to contribute to it, except this one. And if it continues to affect, k will exceed the value of 2, which will become 3. This is the reason our entire loop will stop and we will return answer is equal as 3. That's the reason. You got it? So I hope now you have understood the question. Okay. Great if you understood it. So just one dry run and it was clear. Okay, guys, then thank you everyone for attending. Take care and keep coding. Bye bye.